I'm looking at the top. I'm looking at those four. I'm going to start with this first one here. And I want to first of all describe the shape. And you can take notes right on your handout. The shape of this, stop the video and make your guess. What do you think that is? It's skewed, but it's skewed in the opposite direction from before. So we say that it is positively skewed. And I want to guess where the center is. And when I look at this, I want you to stop, make your guess, and then restart. I'm guessing that the center is here, about 8.5, I'm sorry, about a half. I'm going to put that the center is about 0.5. I'm not going to comment on the other two. I'm going on to the next one. Describe the shape of that. Stop and describe the shape and then restart. Yes, the shape is negatively skewed. I'm running out of space. Don't abbreviate. Where would you estimate the center is? Do that. Stop, estimate, and restart. I would say that the center is here about 19 or 19.1. I'm going to say that the center is there. The next one. I want you to think of some words that would describe that shape. Stop the video, make your guess, restart. Some words people have used in the past are piled up, heaped up, but the best word we're going to use, we're going to say that it's a mound shape. Okay, and the center is easy. Because this is symmetrical, the center is right at 0. Now we're on the last one. Oh, what are some words that come to mind when you look at that? Stop the tape. The word we use to describe when data is about the same all the way along is uniform. This data is uniform. So you will, because it's symmetrical, it's easy to figure out that the center is right in the middle. When it's uniform, it's symmetrical, so the center is at a half. Okay. Now, what I'd like you to do is I'm going to do a quick video lesson of the work we did in class today. We're going to start by making a dot plot of the distilled water that we observed in class on Tuesday. I start by making a number line. I need to draw a line, draw a number line. My pH values range between 6.7 and 9.2, so I need to go down a little to make my number line. I'm going to go down to 6.5 and count up by tenths. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I don't use a ruler. I just eyeball fairly even amounts. And I need to look at my data and fill it in. Okay, so the first data value is 8.01. I round that to the nearest tenth of 8.0. Above an 8, make a nice firm dot. The next one is 7.75, which rounds to 7.8. So above 7.8, even with the 8.0 dot, I make another dot. Then I have 8.32, rounds to 8.3. So above 8.3, even with the others, I make another dot. 7.70 goes right above 7.7, even with 7.8. 7.97 rounds to 8.0. So I leave a little space and I make a second dot above the first 8 dot. Then I have 8.16, which rounds to 8.2. Fill that in. 7.7, I make the second dot above that, even with the second dot above the 8. And then I have a 9. All those are kind of even there. Going on to the next class, I have 9.03, which rounds to 9, 8.31, which is 8.3, 8.30, 8.3, 9.2. My dots are a little small and kind of not pretty. My own work was much prettier, not on the iPad. 8.8, another one. 8.3. I just made an 8.3. So there's 8.8, and I made an 8.3. And then 7.9 goes right in here. And the next class, I have an 8.2. 7.3. You can stop the video if I'm going too fast and rewind. 7.8. 8.7. 7.1. 7.4. 8.3. And then I'm in a new class, 8.5. 9.01. 8.5. 8.6. 8.5. 8.4. 8.9. And this from the last class, only 4 values, 7.1, 6.7, 8.67, which is 8.7, 8.5. Okay, so I finished my dot plot. And the next thing I need to do is I need to evaluate the I need to evaluate the data, and I have to look for 4 characteristics. The first one is center, and I have to figure out where the center of this data is. And so I look to see where would I balance the data. If that number line were like a teeter-totter and the dots were people standing on it, where would I put it to balance? And I wouldn't put it down here because then it would be too heavy on the left, and I wouldn't put it down here because it'd be too heavy on the right. I'm estimating I would put it here. I'm going to say the center is about a pH of 8.3. That's my estimate of the center. It's got about an equal amount on either side. The next thing I need to comment on is the spread. And the spread of the data, for now we're going to use the range. And the data ranges from 9.2 down to 6.7, which is a range of 2.5. So my pH ranges across 2.5. The next is the shape. And if you look at my shape, it looks to me like all of my numbers are over here on the right, and they kind of trail off down here. There's a tail on the left. When data does that, where it's all mounded up like that, we say that the data is skewed. The data is skewed. Now, we also need to say which direction it's skewed. And this data is skewed pointing towards where the negative numbers are. So because they are, we say the data is negatively skewed. The last thing we need to observe are any unusual values, any values that stick away from all of the others. In this case, I'm looking down here at this value. That value of 6.7 is far away from all the others. That means it is an unusual value. So 6.7, and we call those data values that stick away from the others outliers. Outlier. If you don't have any unusual values, in your analysis you would say there are no unusual values. You don't not comment on them at all. So let's look at some, and this is on the hand. I want you underneath what you had on this, I want you to set up an axis. I'm going to go right over my writing. I can't erase it right now. Go over it. 6.5, 1, 2, 3, 4. I'm kind of lining these up underneath. 7.5, 1, 2, 3, 4. Underneath my 8, I have another 8. 1, 2, 3, 4. Underneath 8.5. Have this all set up for class tomorrow. And the homework is to do the 2 problems on the handout. Thank you.